Hi, this is New York Chem Coach. This is questions 40 through 45 from the New York State Chemistry Regents Exam, June 2015. Pause the video, answer the questions for yourself, and then play the video to get the answers and explanations. Okay, here are the answers. Okay, let's take a look. Question 40 is asking about what type of chemical reaction is represented by this equation. And you'll notice that you have lithium and nitrogen forming a compound. And there are 4 words here. These 4 words are the basic reactions. Synthesis is coming together, decomposition is breaking down, single replacement, an element in a compound, trading places essentially, and double replacement, 2 compounds with a switch. These 4 choices you need to know or be able to recognize these equations, and the answer here is number 1. For question 41, we're looking for a molecular compound. So as soon as you see molecular or molecule, you're dealing with nonmetals bonding with other nonmetals. When you have a metal bonding with a nonmetal, then you have a salt, and with salts you have ionic bonds, which is the transfer of electrons. That's not going to be the possibility here, so we're looking for nonmetal. So what do? You can go to the periodic table and find the elements and see where they are. Calcium is on the left-hand side, for example. Chlorine is on the right-hand side. They're going to form an ionic compound. Metals lose, nonmetals gain. If we go back, hydrogen and sulfur. Well, for hydrogen and sulfur, I have hydrogen here, and I have sulfur here. So you might think, oh, metal, nonmetal, but that's not the case. Hydrogen actually is a nonmetal. It literally is an element that's in a group by itself. It's got 1 valence electron, and when it bonds with other nonmetals, we're going to form molecules, and that's actually our answer. But let's check the other choices. For lithium and fluorine, what do I have? I have lithium here, I have fluorine here. Metal, nonmetal, and then the 4th choice, magnesium and oxygen. I have magnesium and I have oxygen. Metal, nonmetal. So the answer is choice 2. Let's take a look at 42. Compared to 1 mole sample of sodium chloride as a solid, I have 1 mole sample as sodium chloride as a liquid. And what's different? Well, anytime I take a salt, which is an ionic compound, again, my metal, nonmetal, which I'm just going to erase that now, the ions will split apart. And when the ions split apart, that means that they have good electrical conductivity. So for salts, again, that would be any salt that's been liquefied or any salt that's thrown in water. And that you'll see an AQ in parentheses. So I get sodium ions in this case, and I get chloride ions. There's my answer. For 43, which property of an unsaturated solution of sodium chloride in water remains the same when more water is added to the solution? Well, certainly the density won't remain the same. Boiling point won't remain the same. And the percent by mass of water in the solution won't remain the same because you're adding more. So the only thing that is remaining the same is the mass of the sodium chloride. Because we're only adding water, we're not adding sodium chloride. I don't know if I said that right. So which property of unsaturated solution of sodium water remains the same when more water is added? So what am I doing? I'm making it more dilute. So the answer there is question 3. That's an interesting question. That doesn't show up that often, so I don't know if that's a new type of question, but we'll have to look out for it in the future. Question 44, which ion combines with barium to form a compound that is most soluble in water? Alright, so for these, barium is the metal every time, but now I'm dealing with 4 different choices as far as the nonmetals. And I have one element, that's barium sulfide, and then I have barium hydroxide, barium carbonate, or barium sulfate. So I'm looking for most soluble in water. So I'm looking for something that is going to dissolve in water of those four choices. There's a reference table. Here it is. And I don't like this table, but we have to use it. And we're looking for solubility of barium when it's bonded, barium ion specifically, bonded with some of the nonmetals, and we'll see what happens. We're looking for most soluble. So we're really looking for soluble compounds. Now take this table. Here's a column of soluble compounds. Exceptions means insoluble. Then we have insoluble here. Exceptions mean soluble. So barium sulfide was the first choice, but barium sulfide is not going to be the answer because it's insoluble. Okay. The next choice, let's go back, was barium hydroxide, which is the answer, but let's take a look at why. Barium hydroxide, if I have barium and OH, typically I would have an insoluble compound, except barium is one of the exceptions here. So it's soluble, and there's my answer. I believe the next choice was barium carbonate, so that's insoluble, that's not an exception for barium, that's here. And the other one was barium sulfate. Usually metals with sulfate are soluble, except now barium is an exception the other way. So you have to just be careful when you're using this table. Take each choice onto its own. We found barium hydroxide as the second choice. Personally, I wouldn't even go over the other choices. As soon as you find it, then you're done. Otherwise, you might get yourself confused. Well, this is New York Chem Coach. This was questions 40 through 44 from the June 2015 New York State Chemistry Regents.